So a little bit about myself. My name is Ben Oberkfell. I'm an Android engineer at the New York Times. Been here since 2017. I work on the games team, so that's the crossword puzzle first and foremost, and then we have some fun, what we call expansion games like Letterboxd and Spelling Bee. They're really fun to play. Check them out. And I'm on Twitter at Ben Likes to Code. My top tweet right now is a link to these slides in this deck. So if you want to take this home, go grab that from the tweet. So caveat emptor here as we get going. There's minimal documentation out there on Jetpack Compose. There's enough to get started running the framework and checking out the 6 gig of dependencies and getting going. But otherwise, you're just kind of leaning on some of the Java doc, the source, other folks' blog posts, and some of the examples in the app. So here's my journey through trial and error in working with Jetpack Compose. And I'd also encourage you to stick around in this room to hear some other perspectives on Compose, since it sounds like it's composed back to back in this room here today. So without further ado, let's talk about my journey into Jetpack Compose. At the Times, we have a thing we call Maker Week. So it's a week where we get to go and drop all of our meetings and basically let all our JIRA tickets sit for a week and go and build something cool. Sometimes people build internal projects for the company. Sometimes people build new feature prototypes. And other times people like to go and get their hands dirty with some new framework. So I decided I'm going to go and make a mess with Jetpack Compose. I saw the talk at I.O., and it blew my mind. If you were in the room at I.O. when they gave the talk, they were doing sound check for Flaming Lips, and they were playing their AV guys were playing the dramatic theme from 2001: A Space Odyssey right as they were delivering the key slide on Jetpack Compose at the I.O. talk. So it was really summed up just like how mind-blowing, how awesome this is. So I decided for Maker Week, let's go and build the mini crossword with Jetpack Compose. So the mini crossword, if you're not familiar with it, it's a 5x5 grid. It's free to play every day. It's fun. It's generally pretty easy to solve. But also, it really lends itself to this prototype, not just for the fact that it's small, but we have fewer of the weird or special or clever puzzles that we often have in the daily puzzles. So you get to a Thursday or Friday, and we have things like more than one letter in a square, or sometimes it's not just across and down, it's across and down and diagonal. Sometimes we have a big overlay at the end to give you a high five when you finish solving. So Mini doesn't really have any of that. It's literally just 5x5 squares in a puzzle. So I set out to figure out how can we build the mini puzzle with Compose using the tools that we have. So Compose forces you into kind of a mental model here of imagining that your UI is a tree. So if like the tree itself, the roots represents the entirety of the UI, you get out to the leaves where it's closer to sort of like the almost atomic components of the molecule that is your screen. So if we were to render or kind of in our minds render the puzzle as a tree, what would be the leaves in this scenario? Well, a puzzle has black squares and white squares, right? So let's get started by drawing black and white squares. So I learned a little bit of this from picking through the examples and going from there. There is a analog to the sort of painting on the canvas features that you often see in Android views, where You can pull out a paint just the same as you're used to with custom drawing, set the color, and then use the same draw rect primitives and the like to do the drawing. You also get, the draw here knows the size of the parent element. So what I want to do here is I want to fill in a rectangle that essentially fills in the entirety of that parent element. So I'm drawing a square, but here the square doesn't know how big it is, or doesn't specify how big it is. The element that lives within is what dictates that size. So here, we're going to draw a black square and a white square. We're going to specify the dimension of the square, how long one side is. And so we're going to wrap these in a container that specifies the bounds. And then we'll call our draw square, which will fill in the drawing right there within that container and expand that out. So when we drop these into a column and in rows in our app, we get a black square and a white square. I've asked these to be 200 dips wide and 200 dips high, and there we go. It's pretty cool. So we got black squares and white squares. That's good, right? We're done. Not quite. We also have, as you play the game, we have cursors. So if you look at this screen here, you have yellow square where your cursor is. You have blue squares where those are the clue that you're actively solving. And then you have white squares that represent squares that aren't involved in what you're doing right now. And don't worry about that red slash right now. That's going to come in later. Just focus on the yellow cursor. So we have these three states for a cursor. We have the active cursor, we have the active clue, and we have unselected. So how can we go ahead and take our square world and extend it to support these cursors? So let's start by defining our colors. And I decided to do this by just taking these and wrapping them in an enum. So we have an enum for none, where we have white, we have the cursor color, the active clue color, that blue, and then black squares. And then I've also defined a selection mode type, which just decides, of those three states we just saw, no selection, cursor, and active clue. So now we can go back to that white square that we had and pass in selection mode into this composable. And then decide what background color to apply when we paint the draw square. So now when we get to here, I can throw these in the row. I'll have my black square just like before. And then I have my white squares with the selection modes here to show what cursor we're rendering. And so these all work great in our little quick and dirty way of seeing if these atoms of the puzzle start to render. So a crossword puzzle square is not terribly helpful without text. You got to fill in a letter in the square, right? So how do we do that? What I want to do is make it so that no matter how tall or wide you've made that square, we're going to scale the letter to fit nice and clean right in the middle. So if it's 200 dips wide, 150 dips wide, I want that letter A in the middle to look nice and centered and happy. So let's go and talk about doing scaled text. I'm going to amend my white square function here even more, and we're going to walk through, this is a lot of code, but we're going to walk through each of these. So first off, I'm going to pass in to my function here the text for the screen, or for the square. And it can be null if, in the case, we don't have any text to render right now. I'm then going to take the dimension of the square, so the width and the height, and I'm going to come up with a scaled pixel font size for that. That's just 60% of the size of the box. So we'll define our text size. Now, earlier, our white square was essentially just this right here in the box. We drew our container, we defined the height and width, we plopped the color in. We got to do a little bit different to get the text in the box. So what Compose provides is this cool construct called the stack. And so it does two things. It lets you paint UI elements on top of one another, and they're painted in the order that they're defined as you write them out. But then also you're able to lay them out in the stack with respect to the edges of the container. So here we're going to take our square that we've defined to be the height and width of our container, and we're going to align that right in the middle. So then we've got our background centered in the middle. The next thing to do is we want to go and take our, so we got our center aligned text, or our center aligned background. Now we want to do the same thing for the text. So if the text is not null, if we have something to paint there, we're going to do the same thing, but we're going to pass in our text, and we're going to give us a style for that font size. So if we do this right, we should be able to see these scaled. And here we go. We have a 150 dip square that's got the letter A that's scaled nice, and a 200 dip square that's got the letter B that's scaled really nice. So again, that looks great. We're kind of approaching from the inside out how we're building these puzzles. From the simplest sort of manifestation of the parts of the puzzle working our way out. So letter squares are great, but the next thing we need are squares that have numbers on them, because the square that starts a clue has got a number in the corner, so we can say 2 across. So how are we going to do that? Well, we're going to make our white square function get a little bit longer yet again. This time we're going to pass in the cell number. It could be null as well, because some cells don't have numbers. Just like we scaled our text size before, we're going to do the same thing for the number size. I'm going to make this 15%. And then now we're going to add our cell number. So if we have a number to paint, we're going to align this to the top left. So the stack is doing a lot of the work for us and making sure that the number shows up in the top left corner the way we want to. Now I don't want it showing up, butting up right against the edge of the board. So I'm going to add some padding. So I'll add 3 dips of padding just to kind of nudge it inward into both directions. And we'll paint that cell number. So here we go. Now we have representation of cells that have no numbers and some that do. So now let's go back to that red strikeout that we have in our example here. What does that mean? Well, one of the features we have in the crossword is that you can check out or you can request that your answers be checked. And when you do, we're going to go and take a great big red slash through any answers that you have wrong and shame you and invite you to go and try again. I kid about shame. It's not. It's learning. So how are we going to go and achieve this strikeout and integrate it into what we've already done? So let's create a composable for the strike through. So we're going to do some painting like we're used to. We're going to go and instantiate a paint. We're going to set the color to red. We're going to draw it on the canvas, and I'm going to get to this stroke width density bit in a little bit here, because this is really cool. Suffice to say, right now I want my stroke width to be 5 dips, and we'll get back to that. So now we're going to draw on the canvas, and again we're just going to start with the we don't know the bounds. We know the bounds that we can paint in, but we're not specifying anything ourselves. So we're going to draw a line from, and these are X and Y, where the 0, 0 is the top left. So we're going to go all the way over to the far right side of the square. So that's the X, Y is 0, the top of the square. And then we're gonna do the same thing to get to the opposite corner. So we can do a forward slash across the square. So we're gonna draw that line. Now, let's get to that width density. Show of hands, how many of y'all have like some kind of utility function you've defined and you kind of pass around for converting pixels to dips and dips to pixels and all that? Like, it's a pain, right? I went to Stack Overflow just to find out like how many questions there are of people asking about converting dips to pixels and vice versa. And there's 260 answers, and this one from 2012 is the top. I mean, it's a pain in the butt. And there's a lot of math and contexts and screens and all this stuff. What if I told you don't have to do that? Width density will do that for you. So here, my paint stroke width requires the value to come in pixels. But I know I want my stroke width to be 5 dips. Compose has this absolutely awesome effect here called width density. So I can say 5 dips, and when you're within this scope here of width density, you can say 2 pixels on the dips and get back pixel values, and that uses the px type. And then I'm going to call value to get that back to a float, which is what the older Paint Android SDK methods want. So instead of using all these utility functions that we've all been hanging on to for dear life, you can just do this in one line and it works. And this about blew my mind when I saw this. If there's any tweetable slide here from this, it's this one bit right here. So now we can go in our stack. Now that we've defined a strikeout, we can align that to the center, make a container for the strikeout that spans the square, and paint it. So now we've rendered an incorrect struct out cell with no selection. I filled in the letter B here. I set the cell number to 5, and then I've instructed it that the cell needs to be struck out. So, great. But this doesn't really help us build a crossword game grid out of it. We need to go and have, actual across rows, down rows, black squares, white squares, all in a crossword grid like you're used to. So how did we pull that off? And so the first thing to do is to take these parameters we've passed into these composable functions and rip those out and adapt it to a model. So first things first, I've defined a square type. So we have a black square and we have a letter square. I've also made a model here that takes a square type, the answer for the what the actual answer for the puzzle is, the cell number if you have one, what the user has typed in to that square if you have one, whether we have requested that square be checked, and that's going to set in motion the process of striking the cell out if they have it wrong. And then we have the cursor selection mode for that given square. And then I've also just, for my purposes, made some convenience constructors here for letters and for black squares. So now that we have a model, I can go and make a letter square. Let's rename white square to letter square because that more reflects what's going on now. So I want 150 dips for my letter square, and I want to say square for letter where the answer to this square is A. So now I can go and construct a model that way. And then we can build the whole puzzle like this. So if we define a board has squares. So we'll just fill in the list of squares for the board. And then the board also needs to know if we have a list of 25, say, the board really should know how many squares live on a side. So we have edge count, which just tells us we have 5 edges, or 5 squares on the edge. So now that we have our model with squares, we want to render this on a board. And, I spent a lot of time kind of wrestling with this one. I started looking at flex rows. Can I kind of plot these out that, in a row and have them lay out that way, and then have columns, and trying to figure out how to make them align and fill the screen. And then I was going through the examples that they have. So when you build the Android X source and go and look around in the Jetpack Compose repo, they have a sample app that has a whole bunch of these constructs working in action. They had one for a table control. And so that seems like it's pretty promising. The demo looked exactly like what I wanted, so I figured I'll try and roll with this and see how it goes. So we'll do a table. And I'm going to walk through each and every bit of this here, so don't worry about this giant slide. But one thing I want to make sure that I draw the squares to the I want the table to take up the entire width of the screen, but I want the cells themselves to be sized so that each of them takes up 1/5 of the table. So there's a straight thing here with constraints that Compose provides you. So I'm able to find, I'm wrapping the entire table drawing in with constraints. And then this gives me the constraints that your view is subject to and how you can draw within it. So I need this in dips to work forward. So again, we're going to use that container width, or that width density trick, to get the pixels from the constraints into dips. But I'm going to say, what is the maximum width that this container can take, and apply that to to dips. And so then if I divide that by 5, or in our case, the edge count, I get how wide a given square can be. So now let's go ahead and draw our table. So when you initialize the table, you're going to give it the number of columns. So we're going to have 5 columns. Next, we're going to loop across every row that we're going to put in the table. So for we have edge count here represents the number of rows. So we're going to do 5 iterations of this row, table row. And when you call table row, the table component is going to call this block once for every column you have, and pass in the column index that it's operating on for you. So we can index into that big long list of squares by saying, okay, what's our row index? Multiply that by 5, add in the column index, and that gives you the X and Y within the table converted back out to an index in the array of squares. And then we can condition on what kind of square type our model represents. Is it a black square? Let's just paint a black square. If it's a letter square, let's paint a letter square with that model. And in both cases, we're taking that derived width of 1/5 of the table and plopping that in to draw with. So we got a board, but it's missing something kind of useful here. I can't see where the squares are. I mean, I know that we have 1, 2, 3, 4, 5, 6, 7, 8 clue squares are there. I know we have the black squares, but I can't differentiate what these cells mean. Really be cool if we have some borders. Lucky for us, the table has some drawing for borders. It's actually a lot simpler than what we wound up having to do for the way we've drawn it in the real crossword app. So let's go and add borders to our table. So now I have an inner border, which is going to be light gray. I want all the cells inside the board to be light gray, and I want the outer border around the board to be black. So now I'm going to calculate that square width, but account for the borders. So this is like a fence post problem. We have 5 squares. We're going to have 6 borders. So we'll take the width of the container in dips, and then I'm going to remove 6 dips for the borders, and I'm going to divide that out by 5. So that'll give me, again, 1/5 of the available space we can use for each square. And then we're going to draw the borders. So we're going to set the default border to be that outer edge, the black color. And then we're going to tell it with outer, we're going to tell it to paint the outer border. Then I can go and iterate over, and I want to paint all the rows, their borders. And we're going to go from, so we're painting the row. And so the first value here in horizontal is we're going to make a horizontal border we're drawing. Row is the index. The row index we're going to draw the border for. 0 until row count, that is the number of columns that we're going to span that border into. So this means I'm going to go from column 0 all the way to the end of the board. If I wanted to stop halfway through, I could do 0 until 2, for instance. Same thing for columns. We're going to walk across the columns, and we're going to say I'm going to draw that border from the top down, right on down to the bottom. Finally, we render the board now, and that actually looks like a crossword grid. That's pretty cool. We're missing something else, though. We're missing clues. So let's create a clue model. And so a clue is going to take a direction. I've created an enum for across and down. The clue needs to know what cells that clue represents. So these are the indexes into the square array that represent those clue squares. And then you have the actual text. So now our board is going to have not just the edge count, not just the list of squares, but we're going to have the list of clues in that game board. Now we also need to keep track of the selected cell where the cursor is. We need to keep track of the direction across or down that you're operating on, so we know which clue to highlight. And then we also need to know which clue that you're actively playing. And so I've added a method here, and I've kind of elided out some of the code because that's not terribly interesting. It's just some array math. We're going to say if you're clicking that corner cell or the cursor cell, this is how we flip directions. So when you click the cursor, you go from across to down. When you select your cursor, we're going to select the selected clue and highlight those of the selection mode. And then finally, we're going to select the selection mode to show your brand new cursor. So next up, we want to wire up clicking so we can actually click around on the board and get it to do something. So in Compose, you have a clickable wrapper. So I can wrap that stack view that we had in our letter square that we were talking about with a clickable, and then that whole thing becomes clickable, and it fires off this lambda here, which I'm going to call onSquareClicked. And then when the square is clicked, that selectSquare method we just showed in the board gets called. And so now I'm navigating the board here, and every time you click that, here we've just alternated from one direction to the other, and it's working. We're navigating the board. That's pretty cool. But we still can't fill anything in. So let's go ahead and in our board add yet one more function, enter letter, and that's going to take the selected cell and set the user answer in the model. And then I've elided some code here for advancing the cursor to the next square. That's, again, just some array math. And for the purposes of this prototype, since we're working in the Android emulator, I've just overridden onKeyDown in the activity that we're working with then. And that's going to go ahead and enter the letter into the board. So now I can start typing and solve the puzzle. And all I have to do is apply that user answer to the model, and the whole thing changes. Note that I never did anything in the UI to take that value and do anything with it beyond just set the value on the model. So finally, we want to be able to check our work and implement that check feature where you can see if you have any answers wrong. So we already have the checked parameter that we've added onto the square model. And then we have parameters for the user's answer that they've entered and the real answer. So now we know if that square's been requested to be checked and you have it wrong, we're going to plop another thing in that stack with the strikeout. Finally, we're going to add a button, check your work. And again, that's going to call, it's on click, is going to call check method on the board. And then when you call check, it's going to apply that checked flag on each and every one of the cells. I'm also doing a convenience thing for the user. Now when you type in a new letter, we're going to clear that checked value on that cell so that it would clear the strikeout and give you another chance to try and get it right. So let's see how it works now. I'm going to fill this puzzle in just like way wrong. And we check our work. Okay, it's taro, no, taco, skate, okay. Sarkiko, right? No. Itchy, there we go. Okay, what's that? Utah. Hooray! Solved the puzzle, got it all right. We did it. We built a crossword puzzle in Jetpack Compose, and we did it in that many lines of code and 35 minutes. So what did we build? We got a Jetpack Compose UI around a data model that's highly similar to the existing model that we're already using in the shipping crossword app. We've decomposed the UI into its most basic components. Black and white squares, you know, it's like the periodic table of the crossword, and then working our way forward in. And we had some fun doing it. So, what now? If you haven't already, and you're looking to get moving with this, I would encourage you to watch the Google I/O talk. It's kind of handy about the mental model that you're going to need to form while you're working with this. If you've already been doing React or Flutter, you probably already have a lot of them. This is probably already in your headspace. And what's cool is if you've been playing with these technologies, it's going to be an easier jump for you into Compose. Get out and check out the Android X source with Jetpack Compose and look at the Material Demos app in that project. It is really helpful. It gives the ability to see things in action and then look at the source, and then you wind up going into the lower components that it's using and looking at their Java doc. Since there's no official documentation on like the Jetpack Compose website right now, that's going to be how you're going to have to figure this out. There's a great blog post called Compose from First Principles. There's a lot of like hardcore computer science in there, but it really explains a lot of the more like theoretical mental model behind how this works. So if you really, if you want to spend an hour and read it, it goes very in depth. It's written by a Googler on this platform team, and it's pretty enlightening. And also, I would encourage you to stick around in this room because there's yet another Compose talk right after mine. And I'm excited to hear some perspectives that might be different than what I've told you here. Since this is all about trial and error, I'm curious what they tried and how it was different from what I did. So with that, thank you very much for coming and sharing this journey with me. We're hiring, so stop by our table over there and say hello. If you want to know more about what we're doing with Android and mobile at the New York Times, doing a lot of fun stuff. So, thank you very much.